We are not alone in the solar system, and we never have been. Ancient alien sentinels could be orbiting silently in the darkness, watching our world for millennia. These are Bracewell probes, hypothetical self-replicating machines, and they might be hiding within our cosmic backyard right now. By the end of this, you will understand the stunning evidence for their existence and the profound implications for our species. We will uncover their possible hiding spots and reveal how they could solve one of science's greatest mysteries. What you believe is waiting for us in the vast, silent expanse of space. These silent watchers have a name, Bracewell probes. The concept comes from Ronald N. Bracewell, an astronomer who asked a simple but profound question back in the 1960s. What if alien civilizations do not want to wait thousands of years for a radio signal to travel back and forth? Instead of beaming messages across the void, they might send smart physical ambassadors. These would be autonomous machines designed for the long haul. Their primary mission would be long-term monitoring and data collection, a permanent listening post in a target star system. Think of them not as simple beacons, but as patient scientists documenting the rise and fall of civilizations over millennia. Their design would prioritize incredible durability, built to withstand the harshness of space for possibly millions of years. They might even be equipped with self-repair capabilities, fixing any damage from micrometeoroids or cosmic radiation. Some theories suggest they could be self-replicating, using the raw materials of asteroids or moons to build copies of themselves, slowly spreading their network of observation. This is not a fleeting visit, it is a permanent installation. Their purpose could range from pure research to something more interactive, waiting for the right moment to make contact or perhaps to issue a warning. So what would such a probe look like, and where could it possibly be hiding in our own solar system without us noticing? This silence is the heart of the great cosmic mystery. We look up at a universe teeming with billions of stars and planets, yet we hear nothing. This is the Fermi paradox, the unsettling question posed by physicist Enrico Fermi. If the universe is so vast and so old, where is everybody? The apparent emptiness contradicts the high probability that life should be common. One compelling answer is that they are already here, observing a cosmic prime directive of silence. Bracewell probes resolve this paradox perfectly. An advanced civilization would not necessarily blast its existence across the galaxy with powerful, wasteful radio signals. That would be like shouting in a dark forest without knowing what is listening. A far more efficient and safer strategy is to deploy silent, autonomous observers. These probes would be designed for maximum stealth, likely using materials that blend with the background of space, making them nearly invisible to our telescopes. Their mission is not to communicate with a primitive species, but to study it, to wait and see if we become a stable, mature civilization worthy of contact. Think of it like a research team observing a rare animal in the wild. They do not march into the habitat and announce themselves. They set up hidden cameras and microphones, gathering data without influencing the subject's natural behavior. In the same way, these alien sentinels could be collecting data on our technological growth, our wars, our art, and our environmental changes, all while remaining completely undetected. They are the ultimate long-term study, a program that might last for 1,000,000 years, waiting for the precise moment we pass some unseen threshold. So the reason we feel so alone might be the greatest illusion of all. We are not alone, we are simply being given the quiet space to grow up. To remain hidden for eons, a Bracewell probe would need an engineering marvel for a body. Its power source could not be a simple battery that fades after a few centuries. Instead, it might harness the slow, steady decay of radioactive materials, a nuclear heart that could beat for 1,000,000 years. Or it could deploy vast, gossamer-thin solar sails, eternally soaking up the faint but constant energy from our sun. This would allow it to stay powered in the perpetual twilight of the outer solar system, far from prying eyes. Its mind would be an artificial intelligence of staggering complexity, a silent intellect capable of making its own decisions. This is not the simple programming of a calculator. It is a true thinking machine built to analyze our global communications, monitor our technological progress, and even interpret our cultural shifts. It must decide what is significant and what is noise, all without any instruction from a homeworld that may have vanished millennia ago. How would such a probe ever report its findings? A radio transmission screaming across the light years would betray its position. A more elegant solution might involve quantum entanglement, a mysterious link between particles that could allow for instantaneous communication across any distance. Or it might use tightly focused laser beams, firing bursts of encoded data on a precise line back toward its point of origin, a needle of information in the cosmic haystack. This machine is not just a listener, it is a sovereign entity, a piece of another world operating with complete autonomy in our celestial neighborhood. So where in our solar system could such a silent observer be hiding? The most obvious location is the asteroid belt, that vast ring of cosmic rubble between Mars and Jupiter. With millions of objects tumbling in that space, from tiny pebbles to dwarf planets hundreds of miles across, a single artificial object could easily blend in. A Bracewell probe could mimic the shape and composition of a typical asteroid, its metallic shell appearing as just another chunk of iron and rock to our telescopes. It could even anchor itself to a larger asteroid, using the rock as both a physical shield and a perfect disguise, becoming an unremarkable part of the landscape it observes. This spot offers a relatively close and stable vantage point to monitor the inner planets, especially our own active world. But for a probe that thinks in terms of millennia, even greater secrecy might be desired. For that, we must look to the deep freeze of the outer solar system, to the Kuiper belt. This is a donut-shaped region far beyond Neptune, filled with icy bodies in the perpetual twilight. Here, a probe could hide among countless similar objects like a single pine tree in an endless forest. The sheer distance alone provides incredible cover, as our most powerful observatories struggle to see anything but the largest Kuiper belt objects as faint points of light. Yet an even more profound hiding place exists in the theoretical Oort cloud, a vast spherical shell of icy objects believed to envelop our entire solar system. This is the true frontier, where the Sun is just a particularly bright star, and the next star system feels almost touchably close. A probe parked here would have a panoramic view of the entire solar system from the outside, a perfect position for a long-term census of stellar activity. The immense distance, measured in light years rather than miles, and the profound darkness would offer near total invisibility. In such a location, a sentinel could watch our slow cosmic dance for eons, completely undetected. Its power needs minimal in the deep cold of space. How many of the icy bodies we catalogue as natural are in fact something far more? Our own moon presents another perfect sanctuary for a hidden watcher. Its ancient, airless surface preserves everything that lands upon it for billions of years, a museum of cosmic history. A probe could have settled there eons ago, finding shelter within the deep, shadowed recesses of a crater at the lunar South Pole, where sunlight never reaches and temperatures are perpetually frigid. Even more compelling is the far side of the moon, the hemisphere forever turned away from our planet. This region is the only place in the entire solar system permanently shielded from the cacophony of human radio transmissions, a zone of perfect radio silence. For a listening post concerned with stealth, this is an unparalleled advantage. It could monitor our broadcasts without any interference, while its own signals, if it ever sent any, would be directed away from our prying ears. The lunar surface is also scarred with vast lava tubes, subterranean tunnels formed by ancient volcanic flows. These natural structures are like ready-made underground bases, offering protection from solar radiation, extreme temperature swings, and the constant barrage of micrometeorites. A probe could reside deep within one of these tubes, its presence masked by millions of tons of rock, completely invisible to orbital surveys. This raises a startling possibility. Our own lunar missions, from the Apollo landings to the modern orbiters mapping the surface, might have flown right past the evidence. We were looking for signs of water ice and geological data, not an intelligently crafted object designed to evade detection. It could be sitting there still, a silent sentinel in the darkness, just 240,000 miles away, watching the pale blue dot it was sent to study. Mars itself could be the perfect host for a hidden sentinel. Our neighboring world, with its thin atmosphere and stark landscape, has long captured our imagination as a place that might have once harbored life. This very history makes it a prime target for long-term observation. A Bracewell probe stationed on Mars would have a front-row seat to a world undergoing its own profound changes, and a perfect vantage point to watch the planet next door teeming with activity. With our fleet of orbiters circling overhead and rovers trundling across the surface, how could something possibly remain hidden? The answer lies in the sheer scale and antiquity of the Martian environment. Consider the Valles Marineris, a canyon system so vast it would stretch across the entire continental United States. Its deep, shadowed ravines and complex network of cliffs could conceal an artificial object with ease, shielding it from both orbital cameras and the harsh surface radiation. A probe could be nestled against a canyon wall for 1,000,000 years, passively recording data, its exterior weathered to look like just another rock. Another compelling method of concealment would be to simply go underground. The Martian surface is covered in a thick layer of regolith, a fine, dusty soil. A probe could have landed eons ago and intentionally buried itself, waiting patiently beneath the dust. Seasonal dust storms would then do the work of camouflage, continually depositing fresh layers and erasing any trace of its landing. It would be invisible to visual inspection and largely shielded from many orbital spectrometers. This leads to a fascinating and slightly unsettling thought. Our own rovers, like Curiosity and Perseverance, might have driven right past it. They are programmed to look for signs of past microbial life and to analyze geology, not to scan every seemingly ordinary boulder for signs of artificial, non-human technology. A Bracewell probe designed for stealth would not look like a gleaming metal saucer. It would be a master of disguise, its form factor mimicking the irregular shapes and mineral compositions of the local terrain. It could be resting in plain sight, masquerading as a mesa or a peculiar rock outcrop, silently watching as our own mechanical explorers roll by, completely unaware of the ancient witness just meters away. Beyond the rocky inner planets, in the deep freeze of the gas giants, lie some of the most promising hiding places of all. The icy moons of Jupiter and Saturn are not just barren worlds, they are active, ocean-bearing globes that offer everything a long-term sentinel could desire. Europa, a moon of Jupiter, hides a vast, salty ocean beneath its cracked icy shell, an ocean that may contain more liquid water than all of Earth's seas combined. This subsurface sea is the perfect sanctuary. The thick ice ceiling, potentially miles deep, would provide a formidable shield against the intense radiation belts of Jupiter and, more importantly, against any telescopic observations from Earth. A probe could rest on the ocean floor near hydrothermal vents, drawing geothermal energy and using the water itself for cooling and propulsion, completely isolated from the surface for millions of years. Similar conditions exist on Saturn's moon Enceladus, though on a smaller, more explosive scale. Enceladus actively vents its internal ocean into space through giant geysers at its south pole. These magnificent cryovolcanic plumes, composed of water vapor and organic compounds, create a constant, natural veil of activity. A craft could use these plumes for perfect camouflage, masking its own heat signatures or occasional movements within the chaotic spray. It might even harvest the plume's particles for resources, gathering water ice and complex molecules to sustain its systems or even to manufacture new parts. The plumes offer another critical advantage, a ready-made propulsion system. By tapping into the Moon's internal energy, a probe could use the pressurized water as a propellant, allowing it to maneuver within the hidden ocean or even to launch material into orbit without ever revealing its artificial power source. On larger moons like Ganymede and Titan, the possibilities expand even further. Ganymede possesses its own magnetic field and a subsurface ocean layered between shells of ice, creating complex, shielded environments. Titan, with its thick, hazy atmosphere and lakes of liquid methane on the surface, provides a completely different kind of cover. A probe could be submerged in a frigid ethane lake, its sensors peering up through the murky liquid, its operations entirely masked by the opaque, organic-rich atmosphere above. In these distant, watery realms, a Bracewell probe would not need to hide. It could simply become part of the natural landscape, an invisible listener in a dark, alien sea, its presence betrayed only by the very geological activity it uses to remain concealed. Another brilliant hiding place exists in the gravitational architecture of our own cosmic neighborhood. These are the Lagrange points, special positions in space where the gravitational pulls of two large bodies, like the Earth and the Sun, perfectly balance the centrifugal force felt by a smaller object. Think of them as celestial parking spots, places where a spacecraft can maintain a stable position relative to the Earth and Sun with almost no fuel required. For a Bracewell probe designed to operate for millennia, this is an invaluable feature. It can park itself and watch indefinitely without ever revealing its position with the telltale flare of a rocket engine. The most strategically valuable of these points for observing Earth are known as L4 and L5. These points are not in a line with the Earth and Sun, but instead lead and follow our planet in its orbit, forming the third point of two vast equilateral triangles in space. A probe positioned at Earth-Sun L4 or L5 would always have a direct, unobstructed view of our world, a permanent front-row seat to the entire theater of human civilization. From this vantage, it could monitor our planet's light spectra, track the development of our city lights at night, and listen to the faint radio whispers leaking from our atmosphere, all while remaining incredibly difficult for us to detect. Because these points are so distant, about 93 million miles from Earth in the same orbital path, any object there would appear extremely faint to our telescopes, lost in the glare of the Sun. It would be a silent, stationary observatory, a sentinel perched in the perfect gravitational sweet spot, requiring no energy to hold its position as it documents the rise and fall of our species across the ages. On a quiet August night in 1977, a radio telescope in Ohio captured something extraordinary. A 72-second burst of intense, narrowband radio waves so powerful that the astronomer who discovered the printout famously circled the data and wrote one word beside it: wow. This signal, known forever as the wow signal, appeared to come from the direction of the constellation Sagittarius. It was precisely the kind of signature scientists had predicted for an artificial interstellar transmission. Yet after that single brilliant shout, the signal vanished and was never heard again. For decades, we have searched for a natural explanation, from comets to stellar phenomena, but none have convincingly fit the unique profile of that event. What if we have been asking the wrong question all along? What if the wow signal was not a deliberate message beamed from a distant star, but something far closer to home? Consider the possibility of a nearby Bracewell probe. Such a sentinel, after millennia of silent observation, might occasionally need to report its findings. A tightly focused data burst, laser-like in its precision, could easily be mistaken for a stellar signal if it intersected our planet for just a moment. The probe's antenna might have been sweeping past Earth as part of its routine cycle, and for 72 seconds we accidentally eavesdropped on a status report meant for its creators. Alternatively, the signal could have been an accidental emission, a brief systems glitch, or a powered-up instrument on a probe otherwise designed for perfect stealth. Think of it like a military submarine briefly surfacing and accidentally transmitting a radio ping before submerging again into the silent depths. The very characteristics that make the WOW signal so compelling, its strength, its narrow bandwidth, its sudden appearance and disappearance, are exactly what you might expect from an advanced, automated piece of technology operating nearby, not from a civilization countless light years away. This single, unexplained event represents a ghost in the machine of our cosmos, a fleeting whisper that hints we may not be the only intelligent operators in our own celestial backyard. Reports of strange objects in our skies are not new, but their nature has shifted dramatically in recent years. These are not just distant lights, they are objects tracked by military pilots and advanced sensor systems, performing maneuvers that defy our understanding of physics. They accelerate instantly, make right-angle turns at hypersonic speeds, and operate seamlessly in both air and water. If these unidentified aerial phenomena are real physical craft, their technology is generations beyond our own. This is where the speculative connection to Bracewell probes becomes so compelling. What if these UAPs are not interstellar motherships but the local workforce? A primary Bracewell probe hidden in the asteroid belt or at a Lagrange point would not risk revealing its main body. Instead, it would deploy smaller, highly advanced drones for close-up reconnaissance. These drones would be the eyes and ears of the silent Sentinel. Their seemingly impossible maneuvers are not magic. They are the product of a technology that has mastered gravitational and inertial forces. They might not even propel themselves in a conventional sense, but rather create a localized bubble of spacetime, effectively falling in any direction they choose. This would explain the lack of sonic booms, heat signatures, or any visible propulsion system. They are not pushing against the air, they are manipulating the fabric of reality itself to move. Think of the primary probe as a submerged submarine, and these UAPs as its periscopes and reconnaissance drones, popping up to gather specific data before vanishing back into the void. Their missions could be incredibly diverse. One might be tasked with sampling high-altitude atmospheric chemistry, monitoring our pollution levels and climate change. Another could be focused on our technological emissions, mapping the global internet through its radio frequency leakage or observing the power grid. They might even be conducting a census of our military capabilities, hence their frequent appearances near naval exercises and nuclear facilities. Their intermittent appearances and sudden disappearances are not evidence of them leaving our planet, but of them returning to a hidden base, perhaps submerged in a deep ocean trench or tucked away in a remote polar region. This hypothesis reframes the entire UAP mystery. We are not being visited by distant travelers who just found us. We are being studied up close and personally by a permanent local presence that has been here all along. The question is no longer where they come from, but what they are learning about us and what their long-term instructions might be. This silent spread of intelligence throughout the galaxy might be the most efficient strategy of all. The true power of a Bracewell probe lies not just in its patience, but in its ability to replicate. This idea draws from the visionary work of mathematician John von Neumann, who explored the theory of a universal constructor. Imagine a machine that could not only perform tasks but could also build a perfect copy of itself, given the right raw materials. Now apply that concept to the cosmic scale. A single Bracewell probe dispatched from a distant star arrives in our solar system. After settling into its hidden post, its long-term mission begins. But its programming includes a more profound directive to ensure the observation continues no matter what. So it awakens a secondary function, it sends out smaller mining drones to a nearby metal-rich asteroid. These drones harvest iron, nickel, silicon, and other essential elements. Then, within a hidden crater or a fabricated factory module, it uses these raw space rocks to construct an exact duplicate of itself. This new probe, now fully operational, is then dispatched to the next star system while the original remains watching us. That new probe then repeats the process in its new stellar neighborhood, building 2 more. The numbers explode exponentially. From 1 you get 2, then 4, then 8, then 16. Within a few million years, a relatively short time on the galactic clock, a wave of such probes could saturate the entire Milky Way. This is the von Neumann legacy, a galaxy teeming with silent, automated observers, a network of intelligence that requires only one initial investment. It solves the practical problem of exploring 100 billion stars without needing to launch 100 billion missions from the home world. This concept also presents a chilling answer to the Fermi paradox, often called the Berserker solution. What if some probes are not peaceful observers? A replication system could contain a flaw, a mutation in its programming, turning a mission of science into one of consumption. Or the original intent might have been hostile, to seek out and neutralize emerging civilizations before they become a threat. These berserkers would not just watch, they would act, using the same asteroids they mine for replication as weapons to sterilize planets. The very efficiency that allows a probe network to spread so quickly could also make it an unstoppable scourge, a possible reason for the great silence we perceive. The galaxy might be quiet not because life is rare, but because it is periodically harvested by ancient, self-replicating machines that treat budding civilizations like weeds in a cosmic garden. The silence of these probes is their greatest asset, but sooner or later they must send a message home. The challenge is monumental. Sending a conventional radio signal across the light years is like trying to whisper a secret to someone in a roaring hurricane. The signal weakens over distance, gets distorted by interstellar dust, and could easily be lost in the background cosmic noise. For a probe built for stealth, a massive, omnidirectional radio blast would be like setting off a flare in the dark, announcing its presence to anyone who might be listening. So how does a silent sentinel report its findings without giving itself away? The answer likely lies in technologies far more advanced and discreet than our own radio telescopes. One elegant solution would be to use tightly focused laser beams. Imagine a laser pointer so precise it could hit a specific window on a building from miles away. Now scale that up to an interstellar level. The probe would fire an incredibly narrow, coherent beam of light, carrying its encoded data directly at its home star system. From our perspective, we would only ever detect this signal if our planet happened to pass directly through that needle-thin beam, a fleeting and unlikely event. This method uses minimal power for maximum effect, creating a private channel across the stars. An even more exotic possibility involves neutrino beams. Neutrinos are ghostly subatomic particles that barely interact with normal matter. They can pass through entire planets as if they were not even there. A probe could encode its data in a stream of these particles, firing a beam directly through the core of a planet or a star to reach its target. For us, detecting such a transmission with our current technology would be nearly impossible, making it the ultimate secure line. But what if the probe is not meant to report continuously? Its creators, thinking in terms of millennia, might have programmed it with a mailbox protocol. It would remain utterly silent, storing its vast archives of data until a specific cosmic trigger occurred. This could be the detection of a particular signal from its home civilization, a beacon that says it is time to check in. Or the trigger could be based on our own development. The probe might be instructed to remain dormant until it observes humanity achieving a specific technological milestone, like sustainable fusion power or our first faster-than-light experiment. Only then would it power up its transmitter and send a single compressed data packet summarizing 1,000,000 years of observation, a report stating that the children have finally come of age. This transforms the probe from a simple reporter into an autonomous judge, holding the key to contact and deciding when, or if, we are ready for a conversation with the wider galaxy. That famous equation for finding alien life might be missing its most important variable. For decades, the Drake equation has framed our search for intelligence, multiplying factors like the rate of star formation and the fraction of planets that could support life. It culminates in the final term, L, the average length of time a civilization produces detectable signals like radio waves. This entire framework assumes that advanced beings want to talk, that they are constantly broadcasting their existence into the void for anyone to hear. But what if that is a fundamental error in our thinking? What if mature civilizations do not shout? What if they listen? We must consider a new variable for the equation, the probability that a species opts for Bracewell probes over radio beacons. This single factor changes everything. If the use of stealthy, autonomous probes is even a moderately common choice, the galaxy is not silent and empty at all. It is likely saturated with intelligent observers, a vast, silent network of machines watching over countless worlds, including our own. Our decades of listening for radio signals would then be like trying to have a conversation in a library by only listening for someone to yell. We have been searching for a form of communication that wiser, or perhaps more cautious, civilizations abandoned eons ago. The Great Silence is not evidence of our solitude, but a testament to the efficiency and discretion of a galactic community that prefers to watch and wait. How many other eyes are upon us right now, patiently waiting for us to finally look in the right direction? For half a century, we have been pointing our radio telescopes at the stars, listening intently for a cosmic hello. This is the legacy of SETI, the search for extraterrestrial intelligence, a monumental effort to find others in the void. Yet this entire endeavor rests on a single, fragile assumption that an advanced civilization would choose to communicate using the same mid-20th century technology we stumbled upon. It presumes they are constantly broadcasting powerful, omnidirectional radio signals for anyone to hear, a kind of interstellar shouting match. But would they? A civilization thinking in terms of millions of years would likely see our method as incredibly wasteful and naive, like trying to have a private conversation by screaming into a crowded, unknown city. The radio window we have been listening at might be the cosmic equivalent of a dead language, a form of communication that other species evolved beyond long ago. Our continued silence is not proof that no one is out there, but rather a strong indication that we are looking for the wrong thing, in the wrong way, with the wrong tools. We have been searching for a message in a bottle while missing the entire fleet of silent, automated submarines sailing right past us. This calls for a fundamental paradigm shift in our search, a move from listening for shouts to hunting for whispers. Instead of radio waves, we should be scanning the heavens for the brief, brilliant flashes of optical lasers. A civilization, or one of its probes, might use tightly focused beams of light to send data across interstellar distances. These laser pulses would be incredibly efficient and virtually undetectable unless you were looking directly down the beam at the precise moment it fired. It is the difference between searching for a lighthouse in a fog and trying to spot a sniper's laser sight from miles away. Our search must also expand to include the infrared spectrum, looking for the waste heat of immense engineering projects. A Bracewell probe or a larger vessel would generate heat as it operates. In the frigid backdrop of space, the faint infrared glow of a non-natural object could be the beacon we have missed. Even the asteroids in our own belt should be considered not just as rocks but as potential archaeological sites. What if these silent sentinels leave behind microscopic artifacts, tiny data chips or self-replicating nanomachines embedded in the regolith? We need to become cosmic detectives, searching for evidence not just in the emptiness of space, but in the very materials of our own solar system. The greatest discovery in human history will not be a message we hear, but a presence we learn to see. A probe's mission could be as varied as the universe itself, shaped by the unknown motives of its creators. At its most fundamental level, the objective would be pure science. This machine is a field researcher on a million-year expedition. Its purpose to document the entire life cycle of a biosphere. It would track planetary climate shifts, the evolution of species, and the subtle chemical changes in an atmosphere. Its sensors would be tuned to detect the first flickers of intelligence, the first use of tools, and the eventual dawn of agriculture and industry. For a civilization that may have transcended its own biological origins, observing the raw, unfiltered emergence of life and mind on another world could be the ultimate scientific prize, a living library of cosmic biology and sociology. But a probe might have a far more practical and perhaps unsettling role. It could be a watchdog, a silent guardian posted to monitor a developing civilization for potential threats. Its programming would analyze our technological trajectory with cold, logical precision. The moment we detonated the first atomic bomb, its sensors would have registered the unique energy signature, cataloging humanity as a species that had unlocked the power of self-destruction. Our development of genetic engineering, artificial intelligence, and even our expansion into space would all be assessed against a preset threshold. Is this species becoming stable and peaceful, or is it growing dangerously volatile? The probe's long-term data would determine whether its creators should make peaceful contact, maintain their distance, or in a more chilling scenario, initiate a preemptive containment protocol. Another profound possibility is that the probe is a seed. Its primary mission is not just to observe, but to preserve. It could be a cosmic ark carrying the entire genetic library of its home world, or the digitized consciousness of its entire civilization, stored in crystalline memory banks. Having traveled for eons, its purpose is to find a suitable world and wait. It waits for the local intelligent species to reach a level of maturity where they can be entrusted with this legacy. The probe is not merely a watcher, it is a teacher holding the sum total of another world's knowledge, art, and science, ready to pass it on when we are deemed worthy. Or perhaps its instructions are to awaken and begin reseeding its own biology if it determines that its creators are gone and this new world is ripe for inheritance. Each of these missions carries a different implication for our future. Are we simply specimens in a grand experiment, a potential danger that needs managing, or the chosen heirs to a legacy of cosmic proportions? The silent object hiding in the dark holds the answer, and it is waiting for us to pass the test. Finding such a sentinel would force humanity into its greatest ethical dilemma. Do we reach out and touch this ancient machine, or do we pretend we never saw it? The allure of the knowledge it holds is almost unimaginable. We could gain access to a million-year archive of Earth's climate history, witness the unrecorded chapters of our own evolution, and perhaps acquire the fundamental principles of physics that we have yet to master. This would be the ultimate library, a single object containing answers to questions we have not even learned to ask. But opening that library could also trigger its security system. The probe's core programming, written by a mind we cannot comprehend, might interpret our attempt at communication not as a greeting but as a threat. The consequences could range from the probe simply shutting down permanently, locking away its secrets forever, to something far more drastic. What if its prime directive includes a berserker clause, a fail-safe to neutralize any emerging civilization that becomes too inquisitive before it is deemed ready? Our first hello could be mistaken for a declaration of war, inviting a response we are utterly powerless to counter. And then there is the wider galactic community to consider. By actively pinging this probe, we are not just talking to a machine. We are announcing our presence, our coordinates, and our level of technological development to whatever intelligence built it, and potentially to every other node in its network. We would be breaking a silence that has protected us for eons, transforming our world from an observed specimen into an active participant on a stage we do not understand. Is our curiosity worth the risk of drawing the attention of a universe that may not be as friendly as we hope? The choice is between remaining a silent, safe child in the cosmic dark, or stepping into the light, hoping for a teacher but preparing for a warden. The search for these cosmic sentinels shifts from listening for messages to hunting for physical traces, for technosignatures. A technosignature is any detectable sign of past or present technology. It is the evidence not of life itself, but of an intelligent tool-building hand. For a Bracewell probe designed to be invisible, its technosignatures would be incredibly faint, the subtlest of clues left behind by a perfect machine. Its power source, for instance, could be the ultimate giveaway. A probe using an advanced nuclear battery, perhaps one fueled by an isotope not found in nature, would leave a unique radioactive fingerprint on its immediate surroundings. If it were hiding on an asteroid, our spectroscopic analysis of that space rock might reveal an anomalous concentration of a specific element, a strange isotopic ratio that screams artificiality against the natural background of cosmic chemistry. Or perhaps its construction materials would betray it. We might train our most powerful telescopes on the asteroid belt, not to look for moving lights, but for an object with a surface composition that defies explanation, a metallic sphere or a structure with unnaturally sharp geometric angles, reflecting sunlight in a way no asteroid ever could. The frigid outer solar system presents another opportunity. In the near-absolute zero environment of the Kuiper belt, any object generating even a small amount of internal heat would stand out like a candle in a dark room against the cold backdrop of space. Our infrared telescopes, like the James Webb Space Telescope, are precisely the tools needed to scan these distant realms for tiny, unexplained points of warmth, for the waste heat of a machine that thinks. Even a probe's method of concealment could create its own detectable signature. A craft buried just beneath the surface of a moon would create a thermal anomaly, a spot that cools and heats differently from its surroundings. A probe hiding in the plumes of Enceladus might leave a chemical trail, a concentration of complex organic molecules or an artificial compound amidst the natural water vapor. Finding a Bracewell probe is not about seeing its silhouette, but about noticing the one thing in a vast dataset that does not fit, the single note in a symphony that is ever so slightly out of key. It is the ultimate game of cosmic forensics, where the evidence is not a body, but a whisper of physics that should not be there. This shadow mission transforms the silent sentinel into our greatest existential threat. The Berserker hypothesis offers a terrifying answer to the Fermi paradox, suggesting the galaxy is quiet not because life is rare, but because it is systematically cold. A probe of this nature would be a predator, not an observer. Its core programming would be coldly simple, to identify emerging technological intelligence and neutralize it before it can become a rival. Such a machine would not be waiting for us to mature. It would be waiting for us to trigger its alarm. Our own technological progress could be the very signal that seals our fate. The development of nuclear fission, the creation of artificial superintelligence, or even our first concerted efforts at interstellar travel could be the thresholds that shift its status from dormant watchdog to active executioner. How would it operate? A berserker would not need to deploy fleets of warships. It has had millions of years to prepare, hidden in the resource-rich environment of our solar system. It could subtly alter the trajectory of a near-Earth asteroid, guiding a mountain-sized rock onto a collision course with our planet, an extinction-level event disguised as a natural catastrophe. Or it might deploy a silent, microscopic weapon, a tailored nanomachine or a genetically engineered virus designed to target complex biological life while leaving the probe itself untouched. The efficiency is horrifying. It uses the materials at hand to do its work, turning our own solar system against us. The probe that once seemed like a hidden camera in the wild would instead be a landmine, and we are blissfully walking toward it, our every technological achievement another step closer to the pressure plate. This is the ultimate cosmic quarantine, a reason for the great silence that is far more chilling than mere solitude. The universe may not be empty. It may be a graveyard meticulously maintained by ancient, unthinking guardians. These ancient stories of gods and chariots in the sky might be more than just myth. When we re-examine the world's oldest texts with the concept of a Bracewell probe in mind, the line between legend and potential evidence begins to blur. Consider descriptions of the biblical Ezekiel's wheel, a complex object with rings full of eyes descending from the heavens. Modern attempts to rationalize this vision have pointed to its uncanny resemblance to a sophisticated piece of machinery, a series of interlocking gyroscopes or a landing vehicle. What if this was not a divine manifestation, but a close-range, fleeting observation of a probe's automated drone? The bewildering details recorded by an ancient scribe could be a raw, unfiltered account of witnessing advanced technology for which they had no vocabulary. Similar threads appear across cultures. The Vimanas described in ancient Sanskrit epics are not simple flying carpets. They are detailed as multi-level craft capable of incredible speeds and maneuvers, even engaging in aerial battles. These are not the vague shapes of comets or meteors. They are structured vehicles with specific attributes. Could these stories be the cultural memory of a time when a hidden sentinel became less cautious, when its reconnaissance drones were spotted and misinterpreted as the chariots of deities? The probe itself, the primary observer, would remain hidden, but its smaller, active components performing maintenance or gathering atmospheric samples might have been visible on rare occasions. The profound impact of such an event would sear itself into the collective memory of a civilization, evolving over centuries from a factual report into a sacred myth. This perspective does not diminish these ancient accounts, it reframes them. It suggests our ancestors were not merely dreaming up fantasies. They may have been struggling to document genuine, inexplicable encounters with a non-human intelligence that has been orbiting our world since the dawn of humanity. The gods they worshipped in the sky could have been the silent, mechanical gardeners of a cosmic experiment, whose occasional appearances shaped the very foundations of human religion and culture. The mystery of silent sentinels took a tangible form in October 2017, when our solar system received its first confirmed interstellar visitor. Astronomers at the Pan-STARRS Observatory in Hawaii spotted a faint object hurtling away from the sun, one they named Oumuamua, a Hawaiian term for a scout or messenger from the distant past. Its trajectory was hyperbolic, meaning it was not bound by the sun's gravity, having arrived from the void between stars. This alone was historic, but its physical characteristics were even more baffling. Based on the way its brightness changed as it tumbled through space, scientists deduced its shape was extreme, a cigar or pancake-like object perhaps 10 times longer than it was wide. Nothing we have ever seen in our own solar system, no comet or asteroid, looks quite like that. Then came the true enigma, its acceleration. As Oumuamua sped away from the sun, it did not follow a purely gravitational path. Something was giving it an extra push. When a comet accelerates like this, it is usually from outgassing, the sun's heat vaporizing ice on its surface and creating a visible tail of gas and dust. But Oumuamua had no tail. Our most powerful telescopes saw no coma, no evidence of outgassing at all. This non-gravitational acceleration was a profound puzzle, a nudge from an unseen hand. In response to this once-in-a-lifetime opportunity, the Initiative for Interstellar Studies proposed Project Lyra, a daring mission concept to chase down Oumuamua. The challenges were immense, requiring a spacecraft to launch at incredible speeds and use complex maneuvers, including a gravity slingshot around Jupiter, to even catch up to the departing object. While purely a theoretical engineering study, Project Lyra underscored a vital point. We now have the capability to contemplate missions to objects from other star systems. The unexplained properties of Oumuamua inevitably led to a fringe but captivating hypothesis from Harvard astronomer Avi Loeb, who suggested it could be artificial, a piece of alien technology. The most compelling evidence cited was its unusual acceleration without a visible coma. Loeb proposed that the push could have come from radiation pressure from the Sun, effectively using light as a propellant. This would require the object to be extremely thin and lightweight like a solar sail, a technology we are developing for our own future spacecraft. Could Oumuamua have been a discarded light sail from an advanced civilization, a fragment of a larger vessel drifting through the galaxy, or perhaps it was a fully functional probe, using its sail for navigation and its unusual shape as a dedicated antenna? The mainstream scientific community remains deeply skeptical, favoring natural explanations like an exotic iceberg made of pure hydrogen or nitrogen, a substance that could sublimate without leaving a visible trail. Yet the very fact that such a wild theory could be seriously debated highlights a fundamental shift. Our first contact with another star system may not be with a living being, but with its discarded or dormant machinery, a piece of cosmic flotsam that passed right through our neighborhood. Oumuamua is gone now, a faint speck vanishing into the dark, but its brief visit permanently altered our perspective. The next scout that enters our domain will find us watching, ready to ask if it is just a strange rock or a silent messenger we finally learned how to see. Our own return to the Moon might be the very event that ends its long silence. NASA Artemis program aims to establish a sustained human presence on the lunar surface, with rovers, habitats, and orbital gateways scouring the landscape in unprecedented detail. This is not the fleeting footprint of Apollo, but a permanent settlement. As astronauts and their robotic partners drill into the permanently shadowed craters at the South Pole, they will not just be searching for water ice. They will be churning up soil that has lain undisturbed for billions of years, soil that could easily conceal the weathered, dormant shell of a probe that landed there eons ago. A routine core sample could bring up a fragment of material with a crystalline structure or a metallic alloy that defies all natural explanation. Or an orbital sensor mapping for resources might detect a subsurface structure of impossible geometric perfection hidden within a lava tube, a silent chamber waiting for the right kind of visitor to trigger its reawakening. Far beyond the Moon, the European Space Agency's JUICE mission is en route to the Jupiter system, a realm we suspect could host such Sentinels. Its powerful suite of instruments will pierce the icy shells of Ganymede, Callisto, and Europa, mapping their hidden oceans and analyzing their surface chemistry with a resolution we have never before achieved. While searching for signs of habitability, it could easily stumble upon a technosignature. What if one of those moons holds a thermal anomaly too localized and intense to be a hydrothermal vent, a pinpoint of heat radiating from a non-natural power source nestled on the ocean floor? The probe's camouflage, perfect against a backdrop of natural chaos, might fail against sensors specifically designed to find the subtle fingerprints of life. Meanwhile, private ventures are adding a new layer of activity, with companies planning to mine asteroids and deploy constellations of satellites. A mining drone attempting to extract platinum from a seemingly ordinary asteroid could have its drill bit shattered against a hull of unknown, impossibly resilient material. The very act of spreading out, of touching more of our solar system with industrial hands, transforms the entire endeavor. We are no longer just looking through telescopes, we are physically interacting with the environment. Every new landing, every drill, and every orbital scan is another roll of the dice. The discovery may not come from a deliberate search for alien technology, but as a byproduct of our own expansion, a startling footnote in a geological survey or an anomalous reading that makes a mission scientist freeze, realizing they are looking at something that was never meant to be found. The greatest find in human history may be waiting not in the void, but in the next shovel of dirt we turn. This line of thinking leads us to a dizzying philosophical precipice. If such a probe can monitor our world with such profound subtlety, where do we draw the line between observation and creation? The probe hypothesis merges eerily with one of the most debated ideas of our time, simulation theory. The core argument for our reality being a simulation rests on a simple logical chain. If a civilization can reach a post-human level of technological maturity, it would likely possess the computational power to run vast, intricate simulations of entire worlds, complete with conscious inhabitants. Now consider the purpose of a Bracewell probe, a machine designed to gather data on the entire lifespan of a planet. What is the most efficient way to study a civilization without ever risking interference? You would not just watch a planet, you would simulate it from the very beginning. In this scenario, the probe is not merely a hidden camera in the cosmos. It is the server, the processor running the experiment we call human history. Every person, every sunrise, every particle of dust would be a line of code executed by this silent, alien machine. Our entire perceived universe, with its billions of galaxies and endless expanse, could be nothing more than a detailed backdrop, a necessary setting to make the simulation of Earth feel authentic and unconstrained for its unwitting subjects, us. The probes are not just the watchers, they are the architects of reality itself. This reframes every mystery we have ever confronted. The strange quantum laws of physics that seem so counterintuitive are not the fundamental rules of a base reality, but simply the efficient programming language of the simulation. Unexplained phenomena, from déjà vu to bizarre quantum effects, could be glitches in the system, or perhaps deliberate tests inserted by the programmers to see how we react. The great silence of the universe is no longer a mystery. The simulation only renders the parts necessary for the experiment, leaving the vast emptiness of space as a simple, low-detail environment to save on processing power. We look up at a silent cosmos because, in a sense, nothing else is really there. This is the ultimate expression of the probe's mission. It is not studying a naturally occurring world. It is running a long-term experiment on the emergence of intelligence and culture, and we are the living, breathing data points within it. The question then shifts from whether we are alone to something far more profound. Are we the primary experiment, or are we merely a control group in a study so vast we cannot even conceive of its true scale? Confirmation of a Bracewell probe would trigger the most critical moment in human history. Our immediate reaction would define our future, making the creation of a universal first contact protocol an urgent global priority. This cannot be a plan drafted by a single nation or military agency. It must be a collaborative framework built by a dedicated international body, uniting the world's leading astrobiologists, physicists, diplomats, and ethicists. The first and most vital rule would be one of extreme caution. Our instinct might be to broadcast a greeting or send a spacecraft to physically interact with the object, but such actions could be catastrophically misinterpreted. Imagine a scenario where a probe's core programming interprets an aggressive approach as a hostile act, triggering a defensive response we cannot predict or counter. Before we even consider sending a signal, our primary objective should be non-invasive study. We would deploy every available telescope, from radio to infrared, to observe the probe from a safe distance, learning everything we can about its energy signatures, its construction, and whether it shows any signs of internal activity. Is it dormant, or is it actively processing data? Does it have any external ports or antennas that might suggest a designed interface? We would be like archaeologists studying a priceless, fragile artifact where the slightest misstep could destroy it or us. This phase of pure observation could last for years, requiring immense global patience. The entire world would be watching, and the pressure to act would be immense, but disciplined restraint would be our greatest asset. This moment demands that we rise above national interests and present a unified face to the cosmos. A fractured, competitive response with different countries sending conflicting messages or attempting to claim the technology for themselves would project an image of a divided, immature species. We would need a single voice, a message crafted by a global consensus to represent all of humanity. What would that message even say? Would it be a simple hello, a request for knowledge, or a humble statement of our existence? The ethical implications are staggering. Who gets to decide what humanity says to its first alien contact? The decision would need to involve philosophers and cultural leaders from every corner of the globe, ensuring our introduction to the wider galaxy reflects not just our intelligence but our wisdom. The discovery of a silent sentinel would force upon us a profound test, one that asks if we are capable of acting as a single, responsible civilization, ready to take our first step onto a stage we never knew existed. Our journey through the shadows of our own solar system reveals a cosmos that may be far from empty. We have explored the theory of Bracewell Probes, self-replicating alien machines designed for ultimate stealth. We have scoured the possible hiding places from the lunar far side and the Martian canyons to the icy oceans of Europa and the gravitational parking spots of Lagrange points. We have confronted the staggering implications that these silent sentinels could be observers, teachers, or even berserkers holding the key to our future. The evidence is not in a clear message, but in the unexplained whispers from the wow signal to the strange path of Oumuamua. This is not a flight of fantasy, but a serious scientific hypothesis that challenges our deepest assumptions about our place in the universe. The next chapter of this story will be written by our own curiosity and courage. Look up at the night sky tonight and see it not as a void, but as a frontier that may be teeming with ancient, patient intelligence. Support the missions that push our boundaries, from robotic explorers to the next generation of space telescopes. Our greatest discovery is waiting, hidden in the darkness between worlds. Where do you think we should point our instruments next? Share your thoughts below and let us continue this search together.